Okay, so for this tutorial we're going to be doing circuit number 2 on the potentiometer. The circuit 2 for the SIK guide, and let's just load it up and see how it is, and base it off the SIK guide. Circuit number 2 it should be page 25. So over here I already have a circuit made, but what I'll do is I'll start a new circuit and show us how to get to this configuration. This circuit over here is different to our first circuit in that we are using more than just the digital pins. If I go back to my Tinkercad file, we could see if we look at circuit number 1, which is just a blinking LED light. In this circuit over here, we are only connecting our LED to these digital pins. Right, so pin 13 is usually the generic pin they use to say power on a light, and so that's all this circuit is doing. And our code is very simple. It is saying turn on a pin, and then put a pin on 13 on high, then put pin 13 on low. And we only have one variable here, or one setup thing, which is we are saying that pin 13 is an output. If we look at our code for number 2, we have a lot more interesting stuff here. Down here at the bottom, this should look familiar. We still have digital write pin high and digital write pin low. So high and low, so that's going to turn our LED light on and off. But where in the circuit number 1 we just had delay 1000, which was 1000 milliseconds, we don't have a number value here, we have a sensor value. So what we are doing here is we are going to have something that is going to change this variable over here. So instead of us manually changing our number, we can put in a different, instead of us manually putting 1000, 1500, 2000, we can get something that represents that sensor value, and we can change it. So let's look at our setups that we have over here. We have some things above our void setup and our void loop. We have these over here, which are INT, or initials. What they are doing is they are defining certain value names to certain locations on the Arduino. For example, over here we have sensor pin is just a word that we are using, and sensor pin is going to equal A03. So A03 on our Arduino is this pin over here is pin A03. We are also going to choose over here LED pin is going to be 13. Now I believe you don't have to put D13 because A for AO is just for analog 0, but if it's just a digital pin, I believe you can just pick the number. And so whenever we want to light up pin 13, we don't have to write pin 13 anymore, we can just write LED pin. And sensor value, we are just declaring it as an int. Sorry, int stands for integer, so it has to be a whole number. We are going to have we're going to say int sensor value, which means we are telling our code that our sensor value is going to be an integer. So let's compare it to our first code. When we had our first code, we had digital write 13, high in brackets. So what this was saying is digital write means this is the operation we want our Arduino to do. We want it to write in the way that it's running. Digital write is like an output type of thing. Digital write, we're saying what pin we're going to do it on. We're going to do it on pin 13, and what's the operator we're doing? We're making it high. So pin 13 high. Over here we have the same thing. We have digital write, so the operation we want to do, we want to write something. Instead of us having number 13, we're saying LED pin. And as we listed over here, LED pin equals 13. So this would be the same as saying digital write 13 high. We use these because when your code starts to get big and gnarly and multiple lines, the individual numbers don't look as friendly. So what we do over here is we use code words so we know LED pin is number 13. It also means that if we have a very long code and we write number 13, if you're ever writing a number more than once, you should probably make it a variable. Over here in code number 1 we use 13 and we use 13. We're using these twice. Right? So if I had this code and I had actually I had a massive long code with all these different operations over and over again. If I wanted to say, well, I actually want to plug my LED into pin number 11, for whatever reason, I would have to go through and change all these 13s to 11, and that's quite time consuming. While if I had it in this case over here where we had LED pin and I copied it, all I would have to do is change this value from 13 to 11. So that's why we use code words. That's why we use words in the place of the actual pins, especially if there's multiple versions of them. So let's start the code. We're saying over here we have integer. Over here, the void setup, we have only one pin to care about. Pin mode, we're saying that our LED pin, so pin 13, is an output. We're declaring that. I believe you just have to declare, like I think, and we'll get up to this in later tutorials if I'm incorrect, but I think you only have to declare for digital pins. So we're saying pin mode, pin 13 is an output. This is the same as our previous code. Then we go to our loop. So what's happening over here? Over here we have Alright, so the first thing is we're going to do sensor value. So sensor value is the pin that we're later going to be using to replace the number inside the delay. Where it was previously 1000, instead we want to get our sensor value. So our sensor value, we can write an equation. Our sensor value is going to equal analog read. So analog read brackets sensor pin. So what is analog read? Analog read is a function in Arduino similar to how digital write. So digital write is using a digital pin, and we're going to be writing, which means digital pin means we're using one of the digital pins, and we're going to be writing, so we're going to be outputting on this digital pin. Analog read means we're using one of the analog pins, and we are reading, so we are listening or inputting whatever value we find there. The use of analog and digital, if you look at your SIK guide on page number 27, we have an example over here of what analog and digital means in the Arduino. In the digital, high or low, high is 5 volts and low is 0 volts. With the analog, it is a range. It can be arranged from 0 volts to 5 volts. And there's 1024 different steps in between. So where 0 volts is 0 and 5 volts is 1023. So it gives you that range and variable, which is good for a potentiometer. So over here we have sensor value equals analog read, and we're going to say what pin are we going to read? Well, because we already have our sensor pin set as A0, we can just use the variable sensor pin. Note, capitalization is important. So if your sensor pin, where pin is P is capitalized, you have to have sensor pin with P capitalized down here as well. So we do this, so it's going to read a value on this. So for example, let's say it's right in the middle. Let's say it's at 5 volts. So it's at 2.5, which means it should be 1024 divided by 2. It should be 512 will be the value. So it should be 512. Because if 0 and 5 volts is 0 and 1024, then the exact middle is 512. So if our potentiometer is right in the middle, analog read is going to be giving us a value of 512, which means our sensor value is going to be 512, which means when we go to do our delay, it's going to get a value of 512, which is about half a second. And that's how we can use this code for that Arduino. So let's go through and build the circuit, because I already have a circuit made over here. But let's build a new circuit, and then let's plug in the code and see how everything looks. This over here is no, just this one over here. Let's make a new circuit. Alright, so what do we need? We need our Arduino. We can just use a small breadboard for this one. Oh, we don't need a large one. We look at our SIK guide and we see what components are necessary. We need one potentiometer. We need one LED light. We need one resistor at 330 ohms. Just ohms. And we need one wire, which we don't have to drag a wire. It doesn't say there what size potentiometer it is, does it? No, it does not. Okay, but we'll get it working. Alright, so let's plug up our circuit over here. We have this LED light, and remember, this flat side of the LED light is going to be the negative side. So just for the way how Tinkercad works, we're going to have to rotate it. And why not go yellow? Let's go the same color as the circuit. It's plugged up to pin 20 and 21, so we'll do that over there. We have this resistor over here, and this resistor is plugged up from negative to there. We have our potentiometer. Let's rotate this to make it fit. It is pin number 678. Alright, and then let's get some power into this. So we want a yellow wire. We want a yellow wire to go from here. Nice. We have that yellow wire. We want a red wire to go to our 5 volts. And we want a black wire going to our negative. And then we want some colored wires. We want this turquoise color over here to be, so our potentiometer, we want this pin over here connecting to that. We want our green pin connected to, I believe in our diagram over here, our green pin is connected to AO1. So we'll just go out here. This is an important pin to put in. Alright, and then we have our last pin is our orange pin, which is going to connect to positive. I believe I did that in the wrong direction. Alright, so this looks like everything's plugged up. We have 5 volts, ground, A0, 13, so everything here is plugged in. We have everything on the same side. This is going to be the voltage divider. So when we have a potentiometer, we have over here on one side of the potentiometer we have 5 volts because it is connected to This side of the potentiometer is connected to the 5-volt line, and this side of the potentiometer is connected to the 0-volt line. So this middle, depending on where this potentiometer is going to be some value between 0 and 5, which is perfect for our tutorial. Now, let's go and get some code. If we go to code over here, we don't want blocks, we want text. Continue. We want to just copy our code that we described previously, and we're just going to paste this code in. And now let's see if this runs. Alright, so right now we have a light buzzing, and so the potentiometer is all the way to this side over here. This is the 5-volt side. So 5 volts should be 1023. So that should give a delay of about 1023, which does look like about a 1-second delay if we look at our simulation. So everything here looks like it's making sense. If I bring this to halfway, we should be having a half a second, and this does look like about half a second flashing. And then if we go to like a quarter, it's a quarter second. So our potentiometer does seem to be working with this system. So let's look at a way that we can modify this circuit. Let's say we already have our sensor value 1 and sensor value 2. So let's stop simulation. Let's adjust this circuit by take off code. Let's add in another potentiometer. Alright, and with this second potentiometer, we're going to use this potentiometer to one of them is going to be how long the light will be on for, and one of them is going to be for how long the light will be off for. So the turquoise is the same thing. We're plugging the potentiometer up to positive and negative, and then we are going to get a let's get a pink cable for this one. And this particular one, we're going to plug this up to A1. Alright, so let's change our code slightly. So we know this over here. We want to say sensor value. So we want to say something like for how long the light will be on will be sensor value, and then we want to say how long the light will be off will be sensor value 2. Right? So this will be our sensor 1, and this will be our sensor 2. We can't just run this code because obviously there's no it's going to say sensor value 2 doesn't exist. Look, if I try to run this code, it should say there's an error over here, because if we look at our error, sensor value 2 was not declared in this scope, so there is no, I have to make it an integer, and then it says it's telling me maybe use the word sensor value, so it's actually trying to be smart and fix it up for us. But okay, so we can do this. So we have over here, we have integer sensor value. So let's just are you going to let me copy? Oh, I have to stop code. Oops. Hold on. Are you going to let me stop code, or do I have to refresh the screen? Oh, that was weird. Okay, so maybe you have to refresh the screen to get it out of an error. So over here, integer value, let's just copy that again. So over here we have sensor value, so we're going to say sensor value 2. And I believe if we still run this thing, at least we know what sensor value 2 is, but it's not going to be adjusted because there is no, we're saying sensor value 2 exists, but we're not saying what the value is. So if we go down over here, sensor value, we can copy this to sensor value 2. Let's just copy this and do this again. Sensor value 2 is going to equal analog read sensor pin. Well, sensor pin, if we look over here, is A0, but we actually want A1. So we could just write A1 here. But as we've established before. It's not the best to do A1. Instead, what we're going to do is over here, I'm going to change this initial value. So sensor pin 2 is going to be called A1. So when we go over here, we can type in sensor pin 2. And now, this looks alright. Let's see if this works now. Alright, so the code is working. That's a good start. So let's see what happens now. I believe this one is going to be for how long the light is on, and this one's going to be for how long the light is off. So let's keep the light on for a quarter, and then it's off for a second. Right, and let's try doing it the other way around. Let's bring this back to full and bring this to a quarter. So the light is only off for a second. So we're using this potentiometer to change the how long the light is on and off. So we can add we could, instead of making this sensor value just choose how long it's on and off, we could also make this sensor value be a multiplier, so we can actually have it as a ratio. But for now, let's just these are just two values that are there. And let's say right now full on is only 1 second. That might not be enough for us, so let's stop. Let's change our sensor value is analog read equals analog read pin 2. Let's times that by 2. So fully opened should be, is that going to work? So fully opened should be 2 seconds. So 1 and 2 and 1 and 2 and 1. Okay, cool. So fully open is now 2 seconds now because I did it as times 2. So now if we bring this to a quarter, that should be half a second. And if this is again half a second. Alright, so we're back to our original point. Right. So that's how you, this tutorial over here, what did we learn? We learned that when you are doing variables, you have to have you have to define it as an integer. Then you, for your digital pins, you got to choose whether, you got to tell the Arduino whether it's going to be an output or an input. For your analog sensors, you can just put in the value in there, and it's going to be a value between 0 and 0 and 1024, depending on whether it is a value of 0 to 5 volts. When you are writing a variable, you have to make sure you use the exact word that they have, including capitalization. And if you're using a same number multiple times, like LED pin, you should make it define it as an integer up the top, so you can just use the word LED pin instead of having to look through 13 the whole time.